Okay, now it's officially recording the live streaming now. So right now we learn three things. One is the web scraping of the static web page, and the next one is web scraping of a dynamic web page. Then is GIFE, the visualization of the social network for network analysis. So for the first one, we will use several different uh, packages. The first one is called Beautiful Soup. Okay, it's called bs4, and the second one is requests. For bs4 requests, we use them to download and analyze the source code of a web page. Okay, for every web page that we are seeing, for example, let me say if you we want to have like two board to be here, like you can just play with your phone. Then if I have any questions, I will ask you. Okay. Um, so for any web page, for example, this web page, the list of S&P 500 companies, this web page is here, and you can see it because whenever you open this link, you type this link, the browser is like a big software combined with a lot of different functions. It's like a lot of different functions with input and output. For example, for this one, the input is a web link. Okay, I enter the web link, I click enter, and it's going to send a signal to a server. Okay, to find out the server wherever in the world storing the related information of this web page. But the information that is stored is not this web page itself. It's a bunch of source code. Okay, it's a bunch of source code. It's called the HTML. The source code can be found here. So this is the HTML source code. If you're using Windows, you basically can just type Control plus U, Control plus U. If you're using a Mac, you use Command plus Option plus U. Plus meaning that you press them together. Okay, so that you will see the source code. So source code is a bunch of code that tells the browser how to present the information. The HTML is a marking language. Okay, it has a lot of tags. So, for example, like T-body. Okay, T-body. It always starts with this tag, then end with a slash tag. For example, this is T-body, meaning that this is a start of a table, and this is a start of a row. And here it denotes the end of a row. And this is a header, table header is a TH. And this denotes the end of a, well, it doesn't have the end of the, oh yeah, here it has the end of the header. So where is the end of the row? The end of the row should be where is the TR? Should be here. So here, this code means that this is a row, okay? This is a row. This is a row. You know what? This is live streaming, so there is a time lag, which is pretty annoying because I cannot check whether you understand or not. You cannot. I'm unable to know like whether you're following me or not. But I can just try to see whether my pace is okay. I hope my pace is not too slow, not too fast, but I'll try my best. If you think it's too fast or too slow, you just type some messages there and let me know. And Frankie can check your message. And if I'm too fast or too slow, then Frankie will let me know. because I cannot see your message now. I'm streaming. I'm talking in front of a camera. So this is a row. So what is a row being presented on the? I'm recording it, right? Yes. On the web page, it is this one, this row. So when you see this row on this web page, you see this. But the computer, this is output. Okay, the input is this whole thing, the table row, and this is table header. It has a lot of table header and slash table header, the th and slash th. So every th slash th, every pair denotes a cell, a cell. If it's a header, we use th. If it's a data in the cell, we use td. So th security denotes a cell, includes the text, the string, the text, security. It is shown here. Okay, here. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 pairs of th. So we should see 9 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And some people may wonder why we have the AH. It's a hyperreference. Hyperreference is like hyperlink. That means whenever you click this text, you will be redirected to a link of this. For example, if you click HEC filings, then you will be redirected to this. And this is wiki HEC filing. Wiki HEC filing. If it is not a wiki link, it is some other link. For example, like this one. Okay, this is TR. It's a new row, and TD, ABT, and ABT should be. Let me close this. ABT should be here. Okay, ABT should be here. If you click the ABT here, you will be directed to a hyperreference, hyperlink of this. So let me see if I click it, whether I will be redirected to the link that was shown. The answer is oh, this is a view source. So actually, it is a source code of this. Why should how do I show the source code of no, ABT? Where's ABT? I know, but I opened it. Yeah, this is a source code. No, I can simply just copy paste. Yeah, if I copy paste it, I will see this. Okay, so this is a web page that opens by copy pasting this link, and this is a page that I'm redirect to by clicking this text. So they are the same web page. I'm just showing you that for everything that you're seeing now, it is the output of a source code of HTML. And HTML is saved in a server. Okay. Right now it's a static web page. That means all of these information, they are generated from the HTML file. HTML file is stored in a server where you can access through clicking this link. So at least this browser has two functions. One is input the link, output this this HTML file, and the second one is to interpret this HTML file and output the the web page that you are seeing. So this is the whole structure of a browser and the web page. Now we are learning how to retrieve the information of this browser. What we want to do is that we want to get all of the information of this and organize them in a Excel or a CSV data file. You probably ask me, why are we doing this? We can basically just, copy, like copy paste. The thing is that if we just copy and paste this web page, you will find that there are a lot of links and the format is going to be messy, and you will also spend a lot of time to organize the data. If you can write a program and ask the program to automatically do that for you, whenever the table is being changed, a lot of people are updating the information of the Wikipedia. So whenever the information is changed, you can simply just click the Python program, and you can retrieve the data the second time, the third time, and in the future. So it has some high fixed cost, but it has a very very low variable cost. Okay. The second thing is that if you have a lot of tables like this, you only see um, one web page. If you have like 100 or 1,000 web pages with a similar um, structure, and if you can basically just write the code for one web page, then use this for loop to retrieve organize the data of all of the other web pages. So this can save a lot of time. Right now we are learning this code. This code will use bs4 soup and requests. Another thing is, how do we install it? We haven't really installed any, but bs4 soup and requests, bs4 soup and requests are actually embedded, installed with Anaconda. You can test whether you can whether it is already installed. If you are not if they're not installed, then just let me know. See, my computer has no problem. It's already installed. Okay, it's already installed. Um, and for this code, students have this code, right? Yes. Okay. For this code, you know what? You don't have to. There is if name equals this, then so we write this in this way because sometimes we have a lot of different functions. So we need to specify which is the main function. You actually don't need to do this. For our teaching purpose, we can basically do this simpler. We can basically do this. Yes. It's the same. Okay. So you can simply look at this code. First, I want to get if I want to get all of the information here, I want to get the source code and analyze the structure of the source code, the HTML file. What I do is that I use the requests.get. It's a function to get the source code's information from a web link. So when I click it and I do this, I will have, a response. But you cannot see it. Okay, you do not see this. If you want to see this, you do the text. What is this? This is a long file. Is a huge string. It is a string. The huge string is a whole HTML file. If you look at this, from the doc type HTML file to the end, body HTML. You will see this body HTML. So this /n means that it changes a line. Okay, so everything, all of the web pages information has been stored in a string. Remember that this string is it's a single quote, and inside we use a double quote. If you use this double quote, then this to this will be denoted as a string, but this and this will be denoted as a string, and the things inside will not be denoted as a string. When we use a single quote at the beginning and at the end, all of the information will be stored as a string. Now we pass the string. So how do we pass it? We use a beautiful soup. When we use the beautiful soup, we use bs.beautiful-soup, and we analyze this whole HTML using a HXML parameter. We can use the other things. For example, you can use bs.beautiful-soup. Yes. So you can have the documentation. Well, maybe I can just watch this documentation. Maybe I should watch this. Not this one. Sorry, not this one. Yeah, I think it's this one. HXML parser. There is a list of all the parsers. Yeah, yeah. So we have different parsers to parse. Parse means that you interpret, explain, understand, analyze the HTML code. So we have the HTML parser, LXML parser, and HTML5 lib parser, different parsers. So there were some advantages and disadvantages between each parser. I think for simplicity of teaching, we just use a very fast one, okay, and it's very lenient. It doesn't really matter what parser you use for this simple code. So when I do this, what do I see? I have a soup file. What is the difference between the soup file and the soup and the rasp.txt? The difference is that in the previous one, well, it is for the previous one you see a lot of /n. Everything is being enclosed in the single quotes. It's a part of string. Here is not a part of string. Okay, it's a HTML file. So you can see that the change line /n sign has been interpreted into a change line. So the line has been changed in the soup. Okay. Now, the reason we use soup is because soup has a lot of functions to allow us to easily find out the the keywords and the tags so that we can retrieve the data easily. For example, if we want to find the first table, if we want to find the first table in this HTML file, we just use the find. Remember, this is to find the first table. If you want to find all of the tables, you use find all, which is this one. Okay, is soup.findAll. You will have a list of 2 tables because this web page has 2 tables. Okay, the second table will be after class test. Okay. For the first table, if I want to have all of the in the first table, we use soup.find and we find the table. But there are a lot of tables. So what table do we find? We want to find the table with a class of wickedable sortable. So how do we know this? We know this because we analyzed this web page first. See, there is a table and the class is equal to wickedable sortable. If it's not wickedable sortable, if they have like different classes of tables, it is maybe some other like class equals Frankie. Then I'll just use class Colin Frankie, right? Now we have you see, we have two tables with a class of wickedable sortable. So that means that we have two tables here. The first one is the S&P 500 component stocks. The second one is this one. Stack and changes the list of S&P 500 components. So we use .find, soup.find to identify the first one. The first one. And what do we get? We will have, oh, I'm sorry, we will have this. What is this? This is a part of the source code of this table. This is a part of the HTML code of this table. Now we just analyze this part to retrieve the data. Frankie, turn off the sign. Yeah. Like I said, the HTML file of the table will start with a T-body, and each row starts with a tag tr and ends with a /tr. And each data, each cell, each small cell that contains the data, if it is header, we use th. If it's the data, we use td. And if you want it to be clickable, it has a link, we use the hyper reference to locate to input the link. Okay. To get the data, we do this. For example, if we want to have the first data, like MMM, how do we locate this data? The table is this bunch of link, and we can use find all. So if we use find all tr, we will have all of the rows. Okay, we will have all of the rows. And the first row is the header. The first row is a symbol security. For example, the first row is this. Is this. It's this thing. We have the symbol, we have the security, and the second row is MMM. It's this. So for the second row, if I want to get this, what do I do? Let me create a variable called first row. It goes table.find all tr1. The second row is no, I'm sorry. The second row is this. Maybe the first data row. The second row is this. No. Second row. Okay. And for the second row, we can find all of the TDs. And the first TD is actually find TD. Okay, and the first TD is this. This is the first cell is this. And if you want to get this, you just use dot text. So now you locate the MMM. Well, you know that the MMM has a line changing sign /n, and if you want to get all of this, you just use, because it's a string, you can simply use this. So now I locate the MMM. If I want to locate the second one, not this, not MMM, but 3M company, this company's name, what do? I do not use find, because find only returns you the first data. I want to return all of the data. I want to get this. So find OTD will give you a list of all the data sets. See, this is a list. All of the elements are separated by the commas. So they're separated. And MMM is the first one. So if you want to get the MMM information, you can also use the first one. And if you want to get the second one, the 3M company, you can simply do this. And if I do dot text, I will have the 3M company. So the rest of the codes are quite intuitive to you. You see, now I'm getting the first row, the second row, right? If I want to get all of the different rows, if I want to get the third row, the fourth row, I simply use the fourth row in table.findAll. One. From the second row to the last. And for every row, I want to find out all of the TDs. And I take the first one to get the ticker, second one to get the security, and the fourth one to get the sector. And for each one, I take the text and I append them into an empty list. Remember, some of you will get bugs in coding that you do not realize that the list has tickers, is in plural form, while ticker is in singular form. So we use a list, append the new ticker, and after get a list of all of the three lists of all the rows information. We have stored all of these tickers information. After we stored all of the tickers, securities, and sectors information, we simply create a data frame using, there were two ways to create data frames, if you still remember, because it's been 2 weeks that we haven't seen each other. I'm not sure if you remember everything that I taught before. The first one is to use dictionary. The column name will be the keys, and the column values, the series, will be the lists. Okay, so I'm using this way to create the data frame. Well, there is another way to use a list of lists to create a data frame by rows. But after that, you need to specify the columns as column names. So now I will have the df as this, and I can simply switch the column order. The reason for us to switch the column order is that the columns may not, well, here the columns get, the columns are in right order, but they're not necessarily in the right order because the dictionary doesn't have, is not ordered. It's not like lists or the string or the tuples. So I save this to somewhere. Well, I haven't defined it. Path. And then I save it somewhere. Where's yeah. So now it should be well. No, not this one. Where is this? Where do you store it? It should be. Oh, web scraping. Yes. So now I retrieved all of the data of the first table in the Wikipedia page as a Excel file. Okay, following this very simple code. Now you have two homework assignments. The first one is I only store the first one is very easy, but it's also likely that you will have bugs. The ticker, security, and sector. I only have the ticker, security, and sector. Ticker, security, the company name, and the sector. I want you to slightly modify this code to also store the subs industry, the headquarter location, and the CIK, and the founded year. Okay, this is a simple one of the first table. This is a simple one. The second one is a little bit harder. I want you to script down all of the information of the second table. Remember that I have already said that here I got the first table by using the soup.find. If you want to get all of the tables, the list of the tables information, you want to have the soup.find all, okay? And you choose the second one. But another thing, a little bit, make it a little bit hard, is that the headers have two columns, the two rows. The first way to address this is that you just do not script down the information of the headers. Is it the fire alarm? No, it's not the fire alarm. Whatever, I just ignore it. You just the first way is that you just ignore it and you just name the column list as whatever you want. Like for example, for this you just name it date, and for this you just name it ticker or symbol or whatever. So this is something that we did for the first table. Well, this is a little bit annoying. This is alarm, but anyway. And or you can basically so when you really script down it, you will find that these are two rows. Okay, you can also get the header from analyzing this source code of the second table, and you have 1 2 3 4 5 6 columns, and you store it in one table and save it in a CSV file. Okay, this is the first part of the beautiful soup. Let me stop recording here. I will give you, maybe I'll give them 25 minutes. What time is it now? 43. Okay. For the second task, you probably just do it after I teach. For the first one, I give you 15 minutes so that you can practice and add modify the codes and add the industry headquarter CIK date first added and found it. Okay, let me stop recording now and give you 15 minutes. Please take the time.